Hello everyone, I am starting example number 13 from probability. Okay, it says that E and F events are independent. Okay, so independent means what is the condition for independency? That E intersection F should be equal to PE into PF. Correct? This is the condition for independent event. Okay, I have explained what is independent in last video. So we have to prove, what we need to prove is that E and F dash is also independent. That means we have to prove that PE intersection F dash is also equal to PE into PF dash. So this is our aim. This is we need to prove. So let us start from Venn diagram to understand what is E intersection F dash. So this is the Venn diagram that we are supposed to show. Suppose this is E event and this is F, correct? This is E and this is F. So we need E and intersection F dash. What is E? Only E. So only E is this, correct? And what is F dash? F dash means everything else except F, except F. So F is this. Everything except F is, let me draw, is this. Everything except F, correct? But we need E intersection F. Intersection means where we have both lines, the red line and blue line. Blue line are showing, the blue lines are showing F dash, and pink lines, what they are showing? E, correct? You can see this is E and the blue lines are F dash. So what will be the intersection where both lines are there? The only region where both lines are there, blue lines also and red line also, both lines are there. This is the region, correct? This is the region. Okay, let me highlight this region. So what it looks like? So can I say that P of E intersection F dash is nothing but this region, and this region is what? This region is actually E minus only this region minus E intersection F. Yes or no? Because the middle region is E intersection F. Correct? Let me show you what is E intersection F. Suppose this is E and this is F. The middle region is called E intersection F. And this total region is E and middle one is E intersection F. If we want only this part, okay, let me color it again, this part, if we want only, so it will be shown as E minus intersection F, correct? This region. So I hope you understood. So this will be nothing but PE minus, by this logic, PE intersection F. And what will be this? These two are independent, so it will be PE into PF, correct? And what will be this? PE is common, correct? So what is left? 1 minus PF. And what is 1 minus PF? 1 minus PF is called nothing but PF dash. This is the formula. Yeah, you can write down 1 minus PF is nothing but PF dash. This is the formula that we are using here. So hence proved, right? This is what we were supposed to prove. If these two events are independent, then the probability of intersection of these two events E and F dash should be equal to product of these two, correct? Means PE intersection F dash should be equal to product of these two for independent events. Okay. Now there is one important conclusion here. If two events E and F are independent, suppose there are two events E and F, means P intersection F is PE into PF, that means they are independent, then for sure E dash and F are also independent. Here, let me show you. E dash intersection F is also this product of these two, because this is the identity which is used for independent events. Third is also true, means E dash and F dash will also be independent. You can use it for MCQs and all, correct? And fourth one, which we just proved it, that E and F dash are also independent. Let me write down. Probability of E and F dash is also independent. So remember, this is a very important identity for independent events, all these four. Okay, let's do one more question. 14th example. So they are saying A and B are two independent events. Okay, A and B are independent events. Then the probability of occurrence of at least one of them means either A or B or both of them. At least one of them means either A or B or both of them is this. So let us solve it. So both are independent. Independent means P A intersection B will be what? P into PB. Correct? This is given. They are asking at least one of them. So at least one of them means A union B. At least one of them means either A or B or both. Correct? So standard formula for this is PA plus PB minus PA intersection B. This we know from our 11th grade knowledge. This is the probability formula. Perfect. Now can you see we can use this here. What we can use here is PA plus PB minus PA into PB, because they are saying this is independent. Correct? So I feel PB is common here, between these two. So it is 1 minus PA. And what is 1 minus PA? 1 minus PA is nothing but PA dash. Correct? Now what we can do? PA is, what is PA? PA can I write from fundamental knowledge, 1 minus PA dash. Can we write? 1 minus PA dash I am writing this. Remaining is same. Correct? Now think, what can we do? I am planning to take this common in these two. This and this common. Okay? I hope you understood. So let me take PA dash common. So what is left? 1 minus PB. Correct? And what is 1 minus PB? Think about it. What is this? This is nothing but PB dash. So hence proved. Yes or no? So this is what we had to prove. See here. This is what we were supposed to prove. And this is what we got. So let us start, based on this knowledge, let us start next exercise 13.2 from NCERT. So here they are saying PA is 3 by 5, PB is 1 by 5. What is PA intersection B? If they are independent events, we know this very well, correct? So PA intersection B is PA PB, correct? PA is 3 by 5, 1 by 5. So it is 3 by 25. This is answer. Okay, next question we will do. You pause it and try it once. So here is the question. Two cards are drawn at a random without replacement from a pack. So without is the keyword here. Okay? So two cards are drawn. So what is the probability? Both are black cards. So first probability that first card is black. Okay? So how many black cards are there? we know out of 52, there are total how many black cards are there? There are 13 hearts, correct? Let me explain the little bit basic about cards. So 52 out of 52 cards, we have 4 suits. All of you write down. Okay, these are 4 shapes: hearts, diamond, spade and clubs. There are 13 hearts which are red, 13 diamonds which are red, there are 14 spades which are black. I am sorry, there are 15 spades. Sorry, it is 13 only, and 13 here. Okay, all are 13, 13, 13. The total is 52. Heart starts from ace. Everything starts from ace. Okay, there is no 1. Ace, then 2, 3, 4, 5, 6, 7, 8, 9, 10. There is no 11. Out into 11 we have jack, queen and king. So there are 13. This also starts from ace. 2, 3, 4, 5, 6, 7, 8, 9, 10. Jack, queen and king. Please write down this basic information of cards. Spade also start from ace, then 2, 3, 4, 5, 6, 7, 8, 9, 10. Jack, queen and king. Here also ace, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Instead of 11, what do we have? We have jack, queen and king. So this is the basic. Remember these three, 3 and 3. They all are called face cards. Understood? The total how many face cards are there? Total 3 plus 3 plus 3 plus 3. Total 12 face cards are there. If they ask how many, total 12. How many black cards are there? Total 13 plus 13 black cards and 13 plus 13 red cards. Please take this picture. So I hope you have written. So they want black cards. So let me tell you black cards. So total black cards are how many? Total black cards are 26. So what will be the probability that first is black card? Will be 26 by 52. If you cut it, it will be 1 by 2. Now how many are leftover cards? Leftover cards will be 51 because 1 is taken out. And leftover black will be how many? Leftover black cards will be 25 because 1 is taken out. So what is the probability that second is black? Out of 51, only 25 are left black. So probability will be 25 by 51 for second card, correct? So this is for first card, this is for second. So we want first should be black and second should be black, correct? So whenever we have and this and that, we always multiply. This is the law of multiplication. If you remember, whenever there is in probability and, then we multiply. For both probability, we have to multiply. If we use or, then probabilities are added. So this is the fundamental law of addition and multiplication. Okay. So this will be 1 by 2, 25 by 51. So final answer will be, write down 25 by 102. This is the final answer. Okay. Next question we can see. Third question. This is a very easy question. We just need to read it carefully. So there is a box of oranges. So let me write down how many oranges are there. So there are 15 oranges total, correct? If you read, they are saying there are 15 oranges and out of which 12 are good and 3 are bad. Okay, so I am writing 12 good and 3 bad. So what is the question? A box of oranges is inspected by examining 3 selected oranges drawn without replacement. So you need to take out 3 oranges. If all the 3 oranges are good, the box is approved for sale. Otherwise, rejected. So oranges you are inspecting without replacement. So this is the key here, without. Okay. Now, find the probability box containing 15 oranges, out of which 12 are good, 3 are bad, will be approved. How come it will be approved if all 3 are good? So suppose, what is the probability that first is good one? First is good one. So what is the favorable? 12 out of total. This is the first probability. After 1, you have taken out 1 orange. So 11 good are left over. 3 are still bad. Correct? This is after taking out 1. So what is the probability that you are taking out now 1 orange and second one is also good one? So what is favorable? Good one is 11 and total is 14 now. 11 plus 3, 14. Total is 14. Correct. After this, what is left over in the box? Only 10 are good. 3 are still there. 3 are bad. They are still there. Total is 13 oranges. Correct. Before total were 15. Then 14. Now total are 13 left over because we have taken 2 oranges. What is the probability that third one is also good? That will be favorable by total. Correct? Favorable is 10, which is good, and total is 13. We want all good. We want this one good and second good and third good. So what we should do? P1 into P2 into P3. We should multiply, correct? So 12 by 15, 11 by 14 and 10 by 13. See if anything will cancel. 5 2s are, 5 3s are, correct? Then 2 7s are, I think. Then 3 4s are. So if you solve it, it will be 44 by 91. Is the probability that all 3 oranges are good and the box will be approved for sale. So this was easy question, right? But the key point here is without replacement. Means if you have taken out, you are not putting it back. That's why number of oranges are reducing. 15 to 14, 14 to 13. Pause it and do it again. See you in next video. Bye everyone.